all these terms. And okay, first one is a circle. A circle is a set of points equal in distance, right, from a given point, which is called the center. Okay, so when you look at this, here's your center. All these points are equidistant from that point. Okay, so you're going to call this circle P. Next thing, a radius is a segment that has an endpoint at the center and an endpoint, I'm going to write this in short form, on the circle. It's important to keep in mind that the radius, okay, is equal to half the diameter, which you should have learned in 8th grade. Okay, so here's the radius. Okay, again, center P, and then we can write, so AP is a radius. Okay, next thing, chord. Chord is a segment with both endpoints on the circle. Okay, so for me, an endpoint there, and then you put them together, they're both on the circle. Here's chord JK. Chord JK. Okay? Next thing, diameter is, okay, this is a special kind of chord that passes through the center. And again, to keep in mind that the diameter is equal to 2 times the radius. Alright, so here you go. Again, with that center, that first center, you've got, okay, so here we go. There's your diameter, goes through in the center, so that's diameter CD. Okay? Secant is a line, okay, so that's important, a line that intersects the circle in exactly 2 places. Okay, so it looks something like this. Okay, it's a line, so you've got arrows on both sides, and we call that X and Y. Okay, and it doesn't go through the center. So this is secant XY. Okay, and then again the arrows. Okay, tangent. Tangent, okay, remember, touch. Okay, so a line that intersects, okay, or touches the circle in exactly 1 place. Okay, so here you go. You've got tangent, a point of tangency right here, and then, okay, so S, Q, T, so tangent, S, T, okay? The point of tangency, so if you look at this one, I'm going to keep it the same color, looking above, okay? Q is the point where tangent ST intersects the circle, okay? Alright, so those two terms go together. Now, central angle. Let's start all over again. Central angle is, this sounds like center, right? An angle whose vertex is on the center. Okay? And two sides are radii, which is plural for radius. Okay? So here you've got the center, that's going to be part of the vertex. So A, P, B. So central angle A, P, B. Okay? Inscribed angle. An angle, okay, whose vertex is on, okay, and I'm going to actually make sure on the center, okay? I'm going to highlight that instead of just on. Back to the inscribed angle, is on the circle, okay? Alright, and two sides are chords, okay? So here you go. I'll keep the letters the same, A, but this time the vertex is on the circle. So here is your inscribed angle. Okay, so that's the difference. An arc is a portion of the edge of a circle, okay, defined by at least 2 points, okay? I like to think of the arc, okay, as a crust. Alright, so here is an arc right here, A, B, okay, so there's your arc right there, and then just to lay some points of interest, that's your center. So that could be, that's just called arc AB, and it's symbolized by an arc over your letters, okay? A minor arc, alright, is an arc with a measure of less than 180 degrees, okay? You know a circle is fully 360, so it can't go for more than half. So here, A, B, okay, so that piece of crust, right? Okay, that's smaller than 180, so that's minor arc AB, okay? So I'm going to highlight that even more. All right, major arc. Guess what a major arc is? An arc with a measure greater than 180 degrees, okay? So obviously this is going to have 3 letters, and my bad, let's go back to minor arc. This has 2 letters, okay? So you know it's major because it has 3 letters. So we're going to do, here's A, here's C, and then here's B. So it's covering more than 180 degrees, Okay, so major arc A, C, B. Okay, and the last term is semi. Okay, so semi, half. Okay, so an arc with endpoints on the diameter. It is always equal to 180 degrees. Okay, so here you go. I'm going to call this arc A, and C again, and then B again, and it's covering half the circle. Okay, so that's semicircle A, C, B. Okay, and that's your vocab. Let's go ahead to the back. Okay, and then what you have are two formulas that you should know. We've done this since middle school, right? So area of a circle, area is pi r squared. And then for circumference, you are used to this, 2 pi r. Okay? And then we can also do, in terms of diameter, pi diameter, right? Okay. So let's do this first one. Area equals pi r squared. So pi, the radius is 12 squared. So they're going to either ask for it in terms of pi, which is 144 pi, or in terms of decimals. You could do the ugly version, 452.4. Now, circumference is 2 pi r, okay, so that's 2 pi times 12, and you're going to get 24 pi, or you can do the less clean version, which is equal to 75.4. I want you guys to do number 2, but remember, need the radius, so you guys know how to find the radius, okay? Now, let's do this one, number 3. Find the diameter of a circle with a circumference of 65.97. Okay, so we're working in terms of diameter, so let's use this formula. Circumference equals pi times diameter. So the circumference was 65.97. Pi doesn't change, and we're looking for D. So you have to divide both sides by pi, okay, to isolate the diameter. So the diameter is going to be 20.99, so that it's approximately 21. Okay? All right. I want you guys to try number 4. Okay? Let's do one last problem together. Okay? Let's do find the area of a circle with a circumference of 26 pi feet. All right? So, first step, you have to do circumference, because that's what you're given. Alright, so this is circumference is 26 pi, okay, equals 2 pi r, and let's divide by 2 to isolate some things. So that's 13 pi equals pi r. Now let's divide by pi, and then the radius is 13. Okay? Now, because the radius is 13, we can plug into area. Area, pi r squared. Area, pi, 13 squared. Area is going to be 169 pi, or the ugly decimal version is going to be 530.9. Now, I want you guys to do 6 in a similar way, okay? So, there it is. Day 1 is done.